Yes. I don't even know what alpha meant. I just was I don't have black words. Can you see?
I will play that. Also gonna compliment. That's the
Huh? Repeat. And you wanted to say the dog. Okay, that's right. Back. It has a big back. Big back. Back. Especially. Cough. Now.
I'm seeing a white shirt.
Extra, extra.
Read all about it. Seeing a white shirt.
But currently,
Okay.
Okay.
okay. Okay, so you have your log now, and that's nothing, so I look like a chipmunk. Do that.
Oh,
Big one. Okay. And I get root canal treatment this afternoon, which is going to be much fun. Right. So. Let's do this, guys. You hit those notes.
It's many years. No, please, you good. You're really there.
I will.
Yeah, introduce the. It's the morning. Oh, sorry.
I want to be there. I'm just thinking of that.
It's like you don't tell like
Yeah,
the last time. I wanted to get up with the last time. Oh, I got. That's okay. I can see it. You catch up.
Absolutely graph. Okay. So remember, guys, okay, when we were drawing these things, okay, we're starting off using the definition, okay, which is that the absolute value of x is equal to x, it's x. We've got those notes. What do you have to know? And then I'll put that graph there. We've got ask, start with the gates of the notes, where to go. And then I'll need notes. Okay, good. Okay. All right. So remember, if we use the definition, what that means is an absolute value graph is made up of what? It's made up of two straight line graphs. All these lessons are recorded, by the way. I'll send you the notes with the links. Okay. So if you were drawing y is equal to absolute value of x, we could write it as we're going to draw the straight line graph y is equal to x when x is bigger than equal to 0. So there's the line y is equal to x, which I drew when x was bigger than equal to 0. I'm going to draw the graph y is equal to negative x, though, when x is less than 0. Okay, they're going to go through the origin. What's the thing called over here? Salient. Okay, sorry, yeah, it's origin, but it's also the salient point. Okay, it's where it's like the turning point, okay, in an absolute value graph. Okay, your domain for all of these graphs is going to be x as an element of real, and range you're going to have to look. Okay, but remember, domain is what goes into a function, a range is what comes out of the function. Okay, right, so you don't necessarily have to have a graph in order to do that. But then we did this, y is equal to negative the absolute value of 2x. Again, what's your definition say? Okay, if what's inside, which in this case is x, is bigger than or equal to 0, then it stays the same. If what's inside is less than 0, then it changes sign. Okay, so I end up with y is equal to negative 2x. So I draw that graph when x is bigger than or equal to 0, but I draw this graph, okay, y is equal to 2x, which goes left to right up when x is less than 0, right? Okay, then we did this. Y, again, we use the definition. Y is equal to absolute value of x plus 3. So it stays the same if what's inside is bigger than or equal to 0, but it changes signs if what's inside is less than 0. That should have been x plus 3 is less than 0. Okay. Simplify that, get x on its own always. So your split happens over there in this case. In this case, the split happens when x is equal to negative 3. When x coordinates are bigger than negative 3, I drew the graph. Y is equal to x plus 3, always labeled intercept. When x values are smaller than negative 3, I drew the graph. Y is equal to negative x. It should have been minus 3 over there. Okay, so we're just using the split. We're not going to always draw them like this. Okay, right. So now we're going to do this one over here. Okay, so I want you to work on the side of your page. Try use the definition to split that up into two straight line graphs.
Two straight line graphs.
Two straight line graphs. Every absolute value of this form is made up of two straight line graphs. So you're going to use the definition. So you're using this definition over and over again. So you're going to be using this definition. What is that definition saying? The absolute value of something stays the same if what's inside is bigger than 0, and change the signs if what's inside is less than 0. So the first thing I'm going to do is rewrite this equation. So y is equal to negative. Okay, I always write down what comes after the, just look here for a second, yeah? Okay, so in this case, I'm going to have one situation if what's inside is bigger than or equal to 0, and I'm going to get another situation if what's inside is less than 0. I'll go right, what's going to go here? Try that. Not trying to trick you. Okay. So according to this definition, what happens here? If what's inside is bigger than 0, then it stays the same, right? So it stays the same what it was, right? So I'm still going to have this negative sign here. That's not affected by this. But if what's inside is bigger than or equal to 0, then this stays the same. So it stays as negative as x minus 2, sorry, and that stays as plus 1. But Masana, if what's inside is less than 0, then what changes? What changes is what's inside the absolute value, right? Again, I'm still going to have this negative here, but now what's inside the absolute value is going to become negative x plus 2. Okay, so that's going to change to negative x plus 2. The plus 1 is unaffected. So what's inside the absolute value? What was inside the absolute value? This over here. If what's inside the absolute value is bigger than 0, then what's inside the absolute value stays the same. But if what's inside the absolute value is less than 0, then what's inside the absolute value changes signs. That's what this definition is saying. Okay, now we're going to make it pretty. So on this side, you're always going to get your restriction. You want to know where your divide line is. So you want to get x on its own. So go do that first. So you're going to have one graph when x is bigger than something, and you're going to have another graph when x is less than something. Are you guys going to do this ear cleaning business?
Yes. My mom told me this morning I have to do it in the shower.
Well, it's just there's no time.
That's recent. Just looking at the bottle. That's one thing that has to, that he's had an infection.
So
Not just twice the eardrops and leave on my.
just to find time, impossible.
I did an appointment.
Yeah. All right. So the one's going to be an A what? When x is bigger than,
or equal to 2.
and the other one's going to be when x is. So you're going to get you're going to draw one straight line graph when x is bigger than or equal to 2, and you're going to draw another straight line graph when x is less than 2. And if I simplify these equations, what does this one become? If I times this negative into the bracket, it becomes negative x plus 2 plus 1. In other words, negative x plus 3. Go to the bottom one. It's sort of making some sense. Okay. So come in, what's the bottom one going to be? Good. X minus 2 plus 1. Good. X minus 1. So what does that mean? Okay. When the x values are bigger than or equal to 2, I'm going to draw the graph. Y is equal to negative x plus 3. What is y? What's the gradient of y is equal to negative x plus 3? Positive or negative? Negative. What does that look like? It's going to go left to right. Down. It's going to have that shape, right? Okay. I'm going to draw the graph when x coordinates are less than 2. Okay. I'm going to draw the graph when x is less than 2. I'm going to draw y is equal to x minus 1, which goes left to right. Up. Where does the split happen? So the first thing I would do is draw in your axis of symmetry, which is where the graph is going to turn. Okay. Go draw in the line x is equal to 2 with a dotted line. Okay, so I'm going to draw in. This is where my split is. Ah. You with me up here? So now what you're going to draw? You're going to draw this graph. Y is equal to negative x plus 3, which has that shape. So it's going to go down when x values are bigger than or equal to 2. I would always go and look what happens at the split. Okay, so where's the split? At 2. In other words, I sub in 2 into that top equation. So when x is 2, go tell me what y is going to be. And on this one as well, when x is 2, if x could be 2, what would y be? Should be the same point. Okay, so when x is 2, what's y going to be? 1. Okay, so whatever that point is, where you sub in, okay, remember the salient point is always going to be where the split happens. So your salient point is going to be at, and if I put in 2 over here, I also get 1, right? So my salient point is at 2, 1. Okay, so let's go put that in over there. So that's 2, 1. Then what's going to happen when x is bigger than or equal to 2? Which graph are we going to draw when x is bigger than 2? We're going to draw the straight line graph. When x is bigger than or equal to 2, I'm going to draw the graph y is equal to negative x plus 3. What did we say that looks like? It's going to go left to right, down. So it's going to go from here, down. We're only drawing this graph when? Okay, we're only drawing the graph y is equal to negative x plus 3 where the x coordinates are bigger than or equal to 2. So it's going to have this shape, right? Is it going to cut the x-axis if it goes downwards here? Is it going to cut the x-axis? Yes, it's not going to cut the y-axis. So when it cuts the x-axis, which coordinate do we know?
2, but then it'll be 2 smaller than 2.
Yeah, so you're getting infinitely close to it. So it doesn't actually get to that point on that one, but it gets infinitely close. So you can think of it that it almost gets, so you could actually put in 1,000,000 lines. Okay, but you couldn't put in 2 itself. But for all intents and purposes, it gets to 2, 1. Doesn't really. This is actually not, the point comes from here. I'm just showing you that they would be the same. Okay. And the number line would be an open dot. Okay. Right. So this graph is going to have this shape. You with me? Okay. So it's going to cut the x-axis, right? What happened? What coordinate do you know in a graph? What's that thing called? It's called the x-intercept. What coordinate do you know for any x-intercept? Y is equal, the y coordinate is 0, right? So if I let y be equal to 0, go find x. I'm going to show you a much easier way to draw these things just now. Let's see again this term. And we have the next step and the next quarter, eh? Activity.
Yeah.
What does that mean?
Okay, you don't want to.
No,
No, actually, you want it, so.
Today, yeah, I'll see you tomorrow.
Yeah. Great.
Right, so when y is naught, Sarah, what do we get? Naught is equal to negative x plus 3, so what's x? X is 3, so this graph goes through 3, 0, which is over here, right? So here's this part of the graph. That's the 1/2. This is the branch. I've drawn the graph y is equal to negative x plus 3 when the x coordinates are bigger than or equal to 2. To the right of 2, right? Now you're going to do what? Okay, now you've got to draw the graph over here. This graph is going to go, I'm going to draw the graph y is equal to x minus 1 when x coordinates are less than 2. Now, if I have y is equal to x minus 1, which has got a positive gradient, again, is it going to cut the x-axis in this case? It is. So go find the x-intercept that goes with this branch.
Oh, and then we're gonna put like that.
Yeah.
Please, look.
Well, good day, we. No, it's all right. Okay. Right, so Lombardi, what do you end up with? X is what? Okay, so another point is 1, 0 on this branch. Okay, so there's 3, there is 1. Right? Is it going to have cut the y-axis? So we need to find that as well, right? If a graph cuts axes, they need to be labeled. So go let x is 0 and find what goes with that. All intercepts always have to be labeled, right? I would always just be safe. Okay, and you don't have to write 3 naught. You can just, if it's an intercept, you can just write 3. Okay. So I would write 3 there. I'd write 1 there, and this is going to be -1, eh? That goes to naught -1. Yeah, I would, Gabby. Okay, so I'm going to say naught -1, which is over there. Then go join those up, and there's the second half of your graph. I've drawn the graph y is equal to x minus 1. Okay, when have I drawn that? For x coordinates which are less than 2. No offense, it's a bit tedious. Okay, but it's just to get an idea, background idea. Right, so go write down for me. You don't have to do this unless I specify. Go write down the domain, the range, and of that graph. No, the graph is one graph. This is not one graph, guys. This whole thing is a graph of y is equal to negative. What you've drawn is y is equal to negative absolute value of x minus 2 plus 1. That graph is made up of 2 straight line graphs. But together, they make up this graph. So this together is the graph of y is equal to negative the absolute value of x minus 2 plus 1. Okay, would we mark it? What would we mark? Okay, in the salient point, what we should really label the salient point. What's the coordinates of the salient point? 2 and 1.
When you did the green on that side, it says, yeah, 3, it's 3-0 or 3-1, the coordinate.
3-0.
No.
Okay, so domain and range. And the equation of the x of symmetry. Except for your hyperbolas, where you're going to have a restriction, your domains at this stage of your life are always going to be the same. What's the domains of all the graphs you do? X is an element of real y, because you can put anything into that without breaking it, right? Okay. So your domain is x is an element of reals. What's the range, guys? Where do the y values, what comes out of this graph? Where do the y, speak to your neighbor, what are the y, what is all the y coordinates you can have on this graph? From where to where? What's the biggest y coordinate? What's the smallest y coordinate? Y is going to do it up and down.
Why? That's
So what's the biggest y coordinate of this graph? 1. And what's the smallest? Go down forever, right?
Yeah.
So you can either write for the range. If we write it as an inequality, we can say y is less than equal to 1. Or you can choose to write it as an interval notation. We're going to try it in interval notation. Yeah,
One is an element of, negative infinity. So we're going, one, but squared.
good. Okay, so choose a language. Doesn't matter which one, means the same thing. Okay. Right, and what's the equation of the axis of symmetry? Gabby? X is equal to 2. Okay. Right, last one we're going to do using the tedious method, then we'll have a break. Okay. Yeah, it is a bit tedious, okay. But it helps you get all of absolute values comes from this. I'm going to show you now. We're going to do it a different way just now. Okay. But let's just do one. You're not going to do this way unless they specify, which I wouldn't do, but I would maybe ask you, what are the equations of each straight line branch? Okay. But I wouldn't ask you to ever draw it like this. Right, try to the next one, guys. Then we'll have a break. Remind me to do register. How many days to go, guys? 3 days to go. Tomorrow into the house, eh?
Yes. What nipple? Yeah, I, but it is cold.
Yeah. We actually have a good video. Joy.
No, it doesn't.
Others that we get. They want us. One interest.
It's missing. Start with the definition. You're gonna have y is equal to, split it up. You're gonna have one situation when, Lasana? I'm gonna get one situation if what?
So if what's inside the absolute value,
So what's inside the absolute value this time?
x minus,
So I'm gonna get one situation if what's inside, which is x minus 1, is bigger than, I always start with this side of the thing. Okay, but I'm gonna get another situation, now if,
x minus one is smaller than zero.
okay. So I start with that. Okay, so if what's inside the absolute value is bigger than or equal to 0, then what's inside the absolute value stays the same. Right, use that logic to get the top row over here. Check with your neighbor to be on the same page. And ladies and gentlemen, I'd like to give a round of applause for perhaps is an Olympic record for the world's longest yawn to 0, right? Yeah. Okay, so if Lambani, what's inside is bigger than 0, what happens? Then what's inside the absolute value? So it's going to be what? Y is equal to? Good. I have a terminator. If what's inside is less than 0, then what happens? Good. Good. Okay, so if what's inside the absolute value is less than 0, then what's inside the absolute value, which is this bit over here, changes signs. Oh, no, you shouldn't. Thank you. You've got the Y over there. That. Right, now go simplify both sides. So on the right-hand side, get x on its own, because you want to know what the split is. And you want to know what each equation is. Salient point. The salient point is we sub in where the split happens into one of the equations. My split's going to happen at 1. Are you all happy with that? And you know what's the top equation going to become?
That was gonna be 2x minus 4 if x is greater than.
So it's going to be 2x minus 2 minus 4. In other words, 2x minus 6. Okay, that's fine. Go get the bottom equation. Bianca, Sunny, you with me?
And 1, right?
Yeah, what's the bottom equation going to be?
Negative 2x minus 2.
Yep. Okay. So I'm doing this, then the first thing I look for now is to find the salient point. I sub in the x coordinate of where the split happens. So first of all, let's just draw in the split. The split is going to happen at x is equal to 1, which is also going to be your axis of symmetry. So the salient point will always lie on where the split happens. And to find the y coordinate, you're going to sub in x is equal to 1 and go find out what goes with that. Sarah, where does the split happen? At 1 what? When x is 1, what's y? Oh, you way ahead. Okay, negative 4. Okay. Right? Did you get that, guys? It would be the same thing for here. Minus 2 minus 2 is negative 4. So my salient point is at 1, negative 4. Now let's think about the shape of this thing. The graph 2x minus 6, is it going to go left to right up an A or left to right down? Left to right up. And why? Because the gradient is 2. And gave me this one? Down. Because the gradient is? Okay. So when to the right of 1, this graph is going to go uphill. And to the left of 1, okay, what? No. I've got something. If x is bigger than or equal to 1, it goes up, yes. And if x is, then the gradient is negative. So it's going to have this shape. Absolute value graphs that you always have this V shape. Okay. So if I do the right-hand side first, on the right-hand side, what am I drawing? I'm drawing y is equal to 2x minus 6. When am I drawing that graph? When the x coordinates are bigger than or equal to 1. So if it goes up from here, is it going to have an x-intercept? Is it going to cut the x-axis? Right, so go find the x-intercept for that branch. How do I find the x-intercept, Paul?
Sub in y equals to 0.
Good. So go do that and solve for x. Wait, when do you leave?
Sunday.
Sunday morning. Eh?
Yeah, I think the first at 1.
Okay. You got your visa.
Does Amber have her?
Yeah, we got it yesterday.
Thursday?
That company was useless. Right, okay.
I'm sorry, I got mine. Mine was quite fast.
They didn't let us know. It's just been sitting there for 3 weeks. Right. Okay, so I get x-intercept, I'm going to have naught is 2x minus 6. 6 is equal to 2x. So what did you get? X is 3. So it goes through 3, 0, which is over there. Label it, get a ruler, join them up. So this is the branch. If I asked you to label the branches, this will be the branch y is equal to 2x
That's horrible.
minus 6. I know it's tedious.
It's
Okay.
painful.
Right. You're going to draw another graph, though. You're going to draw the graph y is equal to minus 2x minus 2 when the x coordinates are less than 1. So to the left of that line. So if it's going left to right down, it's going to have an x-intercept and a y-intercept, right? Okay, so go find both of them.
Oh, right.
So let's check. Your x-intercept, I get naught is equal to minus 2x minus 2. Okay, so you solve, you get x is -1. So it must go through -1 naught, which is over there. My y-intercept, I let x be equal to 0, and you don't have to do any working. You get -2. So this branch goes through naught -2, okay, and -1 naught. Okay, and this is the line y is equal to minus 2x minus 2. Together, what have we just drawn? You've drawn the graph of y is equal to the, what's it, 2 absolute value of
It's -1.
minus 6. Minus 4, sorry.
It's painful.
Okay, it's paid. Right, quickly, domain range and axis symmetry. Yeah. Then we'll have a break.
Upwards.
But extremely, the worst part is you have to remember, you constantly have to remember has to be lower than the. Because otherwise it's like.
You don't get much into it. Okay, so, domain, what's that gonna be, Tlotlo?
The domain is, it's an element of the.
Good. Lana, what did you put for the range?
I said that x is.
Why?
Oh, y is basically equals -4.
Okay,
Y is an element.
or you could write, Nina,
Y is an element of negative. It's -4.
no, start always with the most negative thing.
It's -4.
No, oh yeah, yes, you're right, sorry. Okay, -4, sorry. Include this, up to,
That's
good. And the axis symmetry we all know is x is equal to. Right, guys, it's a bit rough, way to stop today. Okay, 5-minute break. Okay.
Is there any, what way, what do you think is?
Only for hyperbolus.
Yeah, that makes sense.
Okay, because there's a restriction, x can't be the vertical asymptotes.
No one's gonna try. No one.
He's sort of put, he hasn't entirely.
Okay, I use it entirely quick, but it's not really working for it.
I think we can. Yeah, I think we can get him back at some point.
You said micro species. I mean, he is continuous. Oh, yeah, he lost bullet as well. Bullet means they say names. Bullet. Black, black. No, they know it. I bet it's retired. That's everything which old white guy. Yes. Bullet. What did you see? Oh, he was retired. Yeah, he's retired. And he left without notice. Where did he go? I don't like St. Mary's Kid. Oh, how interesting. And then make Selena's Phoenix and like, they still be yes. Go. Yes. Okay, so I commented on your post. I don't know. I'll go through all their tactics. Like, I don't think they commented. No, but that's actually the saddest thing ever. That's why I don't know. We've been a post something and they tell me that's what it's gonna to know. You missed the case. Here I'm as well. I don't think just it was me. Yeah. There's been several times coordinates of aquatics and behavioral. Oh, no. Even that, it's like names. It's like you. 5 and 2. Oh, no. But the 5-year-old is too much. The 2-year-old is.
Am I-
Blog. Blog. Are you blog?
H-O-T-T.
Like the novels, same.
Tomorrow evening
Do I have to go?
on Wednesday at 4 to 6. East. Tomorrow morning is normal.
Well, okay, I'll come to talk when there is a sound. When there's a force, that's when I'll come to. I'm going to leave after this importance. They didn't bring them. So very traffic. Then they say on the.
I don't know if it's compulsory. So is it compulsory?
What?
Oh,
Yeah,
no. You should stop him somehow.
that's what it is, guys.
Oh,
During the day, just goes.
Yes.
No, not fun. Like during the day, you just recheck every day. And the fact that they can see you. At night, people are tired and it's dark. Exactly. Nobody cares, but during the day, too much work.
Yes.
It's the time they get to calling on people.
Because most of the parents can attend, because often parents can't attend in the morning.
Just not gonna compare. Yeah, it's compulsory. Yeah, I like to stay there.
When does Sunny ever come to a compulsory meeting?
She was here last night. Yeah, exactly.
That's why they.
She came to us night ago. Yeah, we'll tell her.
Really?
Damn,
Sunny. How come I didn't see you?
Are you in the same? You are in the same house. We were literally like in a plane together. Like I don't know. In a plane. Yeah, whatever you want to call that thing. A skit. H-A-T-T-N-E-H.
Oh, no, it's.
Sorry. O-T-T-O-G-O. Stop reading. Oh. That's false.
Maybe he should
I'm
have
not on the team.
faster.
Is there a water polo team?
If there's a compulsory water polo meeting today.
Yeah, after school.
Actually.
Is there a water polo team this week? If they invite good people and I don't want to. I can't make it on Saturday. I literally like to scratch my head this
Right,
morning.
guys, let's have a look at it.
Like,
So, right. Devices away, please. Okay. So we're going to get some general ideas about functions. We're going to go over again because quite honestly, functions is a massive section in your matric final. Okay. And it's something you really get to share. So you may have, I don't know if you've seen the exact notes in, it's actually the notes you're going to do in grade 11 in core. Okay. The next few pages, okay, they come from those notes over there. But there's some really simple ideas about graphs which apply to all graphs. Okay, and you've really got to have those concepts down. And they apply to, we're going to end up moving back to absolute value graphs specifically, but I want to show you that the concepts are the same for any type of graphs. Okay, that even if you've never seen a graph before, you can apply the same concepts. And you don't have to start learning things off by heart, you can actually understand what's going on. So we're going to have a little team reading. Okay, we're going to practice our prepared reading. So go to the top of the page. Okay, right. Are you ready? Unprepared reading. Okay, get ready to read. Okay. So we will start with Lambani. Lovely. Okay, I'll give reader of the day after this. Okay, right. Carry on, please, Sunny. Some key ideas. We also study to all. Sorry. No, I'm not going to do that. What did you have to do on Sunday?
Stuff. You know, I love like spider magnets.
The BB pulses.
Right. Okay. Right. Let's go again. Sorry, Sunny. Some key ideas about all functions. Right.
I'm sending, I need to send messages from Madam Chimik.
I'll choose my
That's fine. Okay, so guys, you've got to get that idea in your head. Okay. The graph is made up of how many individual points? An infinite number of individual points. Each individual point has an x and y coordinate. The equation tells you the relationship between those two things. Okay. So an equation tells you the relationship between the x coordinate and the y coordinate. Okay. So if y is equal to 2x, that means it means, okay, right, carry on, please. Sorry, son.
I think she didn't say open bracket.
Yeah. Yes, carry on.
This is the graph where the y coordinate on every point is 2 times its x coordinate plus 1.
Okay, so when you read these equations as every y coordinate is 2 times its own x coordinate plus 1. So what does the graph x is equal to 2 mean? It means the graph where for every single point the x coordinate is 2, which produces a vertical line. Right. Carry on, boy, please.
So if the given x coordinates of a point on a graph, hey.
If given,
Given the x coordinate of a point on a graph, you can find the y coordinate that goes with it by subbing the x coordinates into the equation.
right. So there's a big thing on graph interpretation, and all graph interpretation is these 2 points over here. And likewise,
Just put a comma.
okay. Sorry, yes, if given, comma, yes. Likewise,
Likewise, if given the y coordinates of a point, you can find the x coordinates that goes with it by subbing the y coordinates in the equation of the function.
right. And A, carry on. If you don't.
If you don't understand the above, you will never understand functions. So go and read it again.
Right. We're not going to do that now. You got to do it in your own time. Right. Carry on, A.
So while there may be an infinite number of x and y coordinates on a function, there are a finite number of x and y intercepts on a
Okay.
function.
You need to get your language right. Every single point is made up of an x coordinate and a y coordinate. But an x-intercept, okay, is what? Where the graph cuts the x-axis. And the y-intercept is where the graph cuts the y-axis. Get your language right. Maths is a language. Carry on, please, and A. Doing so well. Okay, right.
Any x-intercept is the point where the graph cuts the x-axis.
Yeah.
Any point where a function cuts the x-axis has a y coordinate of 0. Thus, to find the x-intercepts of any function, you simply sub the coordinate of 0 into the function and solve for x.
Does that make sense?
Yes.
There's not some random rule. X-intercept sub y is equal to 0. Yes, that's what you do. But you're using the principle, although if you know one coordinate, you can find the other by subbing into the equation. And when a graph cuts the x-axis, okay, it's got nothing up, the y coordinate is 0. Terminator, carry on, please.
The number of x-intercepts, zeros, roots.
So when you see those words, they're interchangeable. If I say to you, what are the roots? It means what are the x-intercepts? Okay. What are the zeros of a function? It means what are the x-intercepts? Okay. Carry on.
That a function cannot be more than the degree of its equation. Thus, a linear equation, y equals mx plus c, has a maximum of 1 intercept.
Do you know what we mean by the degree? What's the degree? It's the biggest exponent, right? On the x. So that there, the degree is 1. If it's got a degree of 1, it's got a maximum of 1 x-intercept. Okay, carry on.
A quadratic equation, y equals ax plus bx plus c, has a maximum of 2 x-intercepts.
Okay, so you could have 2 x-intercepts. That's the maximum. It's a parabola. Ax squared plus bx plus c is a parabola, right? It's degree 2, so it's got a maximum of 2 x-intercepts. It could have none. Okay, right. Carry on.
And a cubic equation, y equals ax cubed plus bx squared plus cx plus d, has a maximum of 3.
So that's what a cubic looks like. Okay, you're going to draw this metric. Right. Carry on, please, Bobby.
A y-intercept is the point where the graph cuts the y-axis. Any point where a function cuts the y-axis has an x-coordinate of 0. Thus, to find the y-intercept of any function, you simply sub in the x-coordinate of 0 into the function and solve for y. A function can have a maximum of 1 y-intercept.
Okay, so maximum of 1, otherwise it's not a function. Okay, we'll worry about that in metric. Right. Okay, carry on. Oh, no, you had a mouthful of food. Right, carry on, Bianca. Okay.
y-intercept. Remember, x-intercepts have coordinates.
Something zero.
Something zero, and the y-coordinates have, zero something. I will now read through the whole page again.
Okay, in your own time. Those are really fundamental ideas about graphs, guys. Okay, graphs make up about 25% of your paper one in the thing. Okay, probably more actually, probably about 40% if you take cubics into account. Yeah. That's right for you. So get to know them now. Yeah.
So the degree on the ends.
The degree of a function is that the biggest exponent that an x has on it.
So then the degree on the x variable still defines the maximum amount of
Yes.
x-intercepts.
Yes.
Then
That's
wait, what was the degree of function?
what?
Degree of function?
The biggest exponent on an x. So this x cubed is degree 3. Okay, x squared is degree 2. You with me? Okay, right. Right. Sorry, I know there's a lot of reading, but it's important. Right. Other things I better remember. Let's go, please, Fasana.
As a degree of an equation.
Okay.
Use the outside voice.
Right.
The last bit. The values that go into a function, the independent values, the values on the horizontal axis, all the x coordinates of a function on the Cartesian plane are called the domain values of the function.
Okay, so domain goes into some function, the independent values in physics. Yeah. Carry on.
The values that come out of a function, the dependent values, the values on the vertical axis, all the y coordinates of a function on the Cartesian plane are called the range values.
Okay, so the different language we use, independent variables go into a function, the dependent variables come out. Okay, in a time displacement function, what's independent? Time. Okay, displacement, okay, whatever. Domain is what goes in, range is what comes out. So only stay with us. Generally, you work with x and y coordinates. X coordinates go in, y coordinates go out. Okay, right. A function can be thought of as an instruction and a set of coordinates, i.e. a graph. From an asymptote, please, Sarah. An asymptote.
Right, in Hermitage.
Okay, right. So then remember the Asymptote River in the south. Okay, it's full of crocodiles. Okay, there actually is a river, you can Google it, called the Asymptote River. Okay, which is full of crocodiles. Okay, so an asymptote you can get very close to, but never touch it. Okay, actually a bit of a lie. Right. Okay, hyperbole have a vertical asymptote. Sorry?
It says all the hippos.
Or this impulse, yes. Okay, hyperbole, you have a vertical asymptote and a horizontal asymptote. Okay, so the only graphs that you're drawing this year which have asymptotes are your hyperbole, okay, which has a vertical asymptote and it has a horizontal asymptote. Right. Asymptotes, carry on from there. Sarah, a few more points. Asymptote should always. For example, horizontal asymptotes are y is equal to something. Vertical asymptotes are x is equal to something. Right. Toto, the parabola.
Oh, the parabola is the only function that we work with this year that has a turning point. This must always be labeled with zero.
The parabola as a turning point, right? Okay. Carry on.
A function is increasing if it has a positive gradient. It is going up from left to right. A function is decreasing if it has a negative gradient. It is going down from left to right.
So some functions change whether they're increasing or decreasing, like a parabola. Okay. A parabola is always, well, this red, but is it increasing or decreasing? If you're going from left to right, are you moving uphill or downhill? Uphill. So that's where the function is increasing. In green here is where the function is decreasing. So this changes from a decreasing to an increasing function. This point where it turns, we say the function is actually stationary. Okay, so it goes decreasing, stationary, increasing. The other functions that you work with are usually one or the other. Okay, so that exponential graph, increasing, if you don't have exponential graphs yet, I don't think so.
No.
Okay, but just that's what it looks like. Would that be increasing or decreasing? Okay. A hyperbola, does it change or is it one thing? Okay, this one will always be what? Increasing or decreasing? If you land, I'll think of those things at the airport. If you land on this thing, conk. Okay, think of the graph as always being something that's moving from left to right. You land here, will you be shot down or up? You land here? Down. Going from left to right. You've been shot downwards every single time, right? That's a decreasing function.
But when it's in a different.
Okay. Doesn't matter which quadrants. Here, well, this one would be what?
Increasing.
Only increasing. So it's a strictly increasing function. When parabolas change between increasing and decreasing, right? Okay. Straight lines strictly increasing or decreasing, absolute values change. Okay. Right. Okay. Transformations of graphs. The great thing is that graphs can be largely understood by understanding transformations. Transformations means what? Movements of the graph. Reflections, so basically it's made up of two things. Translations, which means moving up and down and across. Okay, and reflections, okay, which is folded over something. So the first thing is vertical shifts. To cause a vertical shift of P, you add P to every Y coordinate. Okay. So if I had Y is equal to 5x cubed plus 7x. Okay. And I wanted to move the whole graph 3 units up. Okay, I simply add 3 to the end. Because what happens then? Every Y coordinate is 3 more than it was before. And if a Y coordinate is 3 more than it was before, what happens? That point moves up by 3. Okay, so the same logic works for all graphs. I'll show you something on this note. Okay, so try to finish the rest of that page. Right. So what was that first equation?
The negative.
No, it's good to one.
What? Is this like,
Yeah, you can.
I don't get it.
Okay, we'll carry on next time. Okay, just one thing. Just wait 1 second, actually. Right. Okay. So what was that first? Right. Just thank you. Give me a second. Okay. What was that first equation? Y is equal to x cubed. No, the x cubed one. X cubed plus 7x was it? Okay. So the original one. I'm just going to show you something here. It doesn't matter that one. But so I gave you this graph, guys. Here's the graph of y is equal to x cubed minus 2x. Right? There's the graph y is equal to x cubed minus 2x. So if I wanted to shift that 5 units up, what equation would I enter? I'd enter another equation. That was the original one was x cubed minus 2x. Okay. And so now I'd enter y is equal to x cubed minus 2x and plus 5. And what should the effect be? That whole graph should be picked up. Every single point has moved 5 units up. Okay. To cause a shift in a graph, you simply add a constant to the end of the function. All right, guys. Thank you.
What do you have done?
Well, if they else. I
Oh,
hate to think that I'm see out to be.
Double it.
The one that's there, am I right?
I don't know.